vision to see what makes things work and what imaginative minds can dream up. We're going to look at boats today. Not just any boats, but the incredibly exciting hydroplanes. The big ones, and the ones you can use right now. We're going to learn what makes a V8, high-octane, 3-point hydroplane run. We're going to learn how you can build one and use it by radio control. This is the place where the action is. You're always a part of our club here on Professor Ginz's Machinorama. This is one fast V8 Hydro, and it's named American Eagle. This is the guy who drives it. His name's Paul Droulard. Tell us, how fast does this baby roll?
The 5-liter limited hydroplane will hit the end of the chute about 112 miles an hour.
And that's just tiptoeing over the tops of those waves. First down! What does all this stuff in the name mean? High compression, V8, 3-point, hydro. Now, the V8 part comes from the configuration of the engine. This engine has 8 cylinders. That's the 8 part of the V8. And the V part, well, you can see these two banks form a V shape. That's because there are 4 cylinders on one side of the engine and 4 on the other, and it forms a V. Add them up, you have a V8.
We've taken a lawnmower engine and cut it open so that you can see how an engine works. The heart is over here. That's the crankshaft. That's the part that turns around and around. It's connected to the connecting rod and to the piston, which rides inside of the cylinder. The way the engine makes power is this. It starts here, with fuel and air coming up in through the carburetor, gasoline with air. If it was fuel injected, it works a little bit differently, but pretty much the same. The gas and the air come up through this valve over here. This is the intake valve. That comes up, and while that's opening, this piston is going down, and it's sucking in. Just like your vacuum cleaner at home, and it's sucking in that gas and that air. Goes down to the bottom, and now the valve closes. The valve closes, and the piston squeezes into a little space. That's the compression stroke. Comes up and compresses it, gets to the top, now the spark plug goes to work. It fires a spark. Now, we all know what happens when you have a spark and you have gasoline. It burns. Now, you have to understand something. The smoke that comes out from that burning takes up a lot more space than the gas in the air did. So it pushes the piston down. This is when the engine's actually making power. This is the power stroke. You notice what happens when it goes down? This valve is opening. That's the exhaust valve. As the piston rises up, it's pushing that smoke out the exhaust valve and out the exhaust pipe and getting rid of that old smoke. And that's a complete cycle of the engine. Now, where does the high compression and the high octane come in? Well, this small space here is the combustion chamber. The smaller the space that you squeeze that gas and air into, the higher compression a motor is. The only catch is, in order to have high compression, you need special gas called high octane. Combine high octane with high compression, and you make more power. I love more power.
And the 3-point hydro, that has to do with the shape of the hull. These here are the sponsons. The boat rides on top of those, and the 3rd point is the propeller in the back. And that's how this boat dances on the top of the water.
The bottom part of the boat, or the part that goes in the water, is called the hull. This is a displacement hull because it goes through the water. You see displacement hulls on ocean liners, tugboats, and other heavy boats. The advantage is when you put a lot of weight in them, they remain very stable. The other type of hull is a planing hull. They're built for speed. Now, a planing hull gets up on top of the water once it gets moving, and only a very small portion of the hull is actually in the water. Most of it's in the air. The disadvantage of these is put too much weight in it, and it never gets on plane. Then it becomes the most inefficient hull and uses lots of fuel, and it only goes very slowly. The other problem with them is, in big waves, they can capsize or swamp very easily. And of course, the ultimate planing hull is the hydro. This is our hydrodynamic tank. We're going to use this to simulate a boat moving through the water. First, we're going to go to the barrel and open this valve. Water's going to come out and come through this long pipe and out and into the tank. Then instead of the boat moving across the water's going to move past the boat. Let's start her up. We pull it, and you can see the water flowing through. And here it comes, dynamite. Let's see the displacement hull. You can see the way it just rides through very stably. Let's see what the planing hull does. We put that in, and it jumps right up on top of the water, but it kind of dances around, not too stable. And finally, the hydro, the least stable of them all, but also the fastest. Okay, these machines are really bitching, but you're not quite big enough yet to climb into one of these? How can you have some fun? Well, check these out.
I'm at the Capitol Lake Radio Control Model Boat Meet. Let me tell you something. These babies scream. You know what they run on? Alcohol. Same thing that the real monsters we just scoped out run on, but you get to drive on. Let's go inside and see what makes these babies tick. Hey, I've only got 3 minutes to get back to the shop in the time you're going to watch this commercial in. Gotta go.